All right, so we've been talking a lot about dependent events, where one event, the outcome of one event, is dependent on the outcome of another event. All right, now sometimes events are dependent and sometimes they are not. So if they're not dependent, we call them independent events. So an independent event is an outcome or is an event in which the outcome of one event does not affect the outcome of another event. So you might think about rolling two dice, right? So the outcome of the first die does not affect the outcome of the second die, right? They're independent of each other. Their outcomes do not affect each other. So let's take a look at example 6. This is a fairly straightforward example. And we're just asked to evaluate whether these events are independent or not. So in the first part, E is the event that the first card drawn is an ace, and F is the event that the second card drawn is an ace. Okay, so you have to think about if we want to evaluate whether they're independent or not. We want to figure out is the outcome of F dependent on the outcome of E, right? So in this case, these are not independent events, right? So the answer is no, these are not independent events because the second card drawn depends on what happens with the first card. If you draw an ace, then you're going to have fewer aces to choose from in the second draw. If you don't draw an ace, you'll have more aces to choose from. You'll have all 4 aces to choose from in the second draw. So no, these two events are not independent, right? The second draw depends on the first. All right, let's look at the next one. It says E is the event that a coin lands heads on the first toss, and F is the event that a coin lands heads on the second toss. Okay, so think about, does the first toss affect the second toss? The answer is no, right? But the answer to the question is yes, these are independent events because the outcome of the first toss does not affect the outcome of the second toss. Okay, so the second toss does not depend on the first toss. Okay, so they are independent. All right, let's take a look. Let's look a little further here. That was a fairly quick example. Let's take a look at the definition of independent events. Okay, if A and B are independent, then the probability of A given B is just the probability of A, right? Because we don't care what happened with B, right? So all we care about is probability of A. Probability of A is probability of A, and it does not depend on B. So the probability of A given B is just the probability of A. Same way with the probability of B. Okay, the probability that B happens given that A happens is just the probability of B, right? Because we don't care what happened with A, because it doesn't affect what happens with B, right? So the probability of A given B, or sorry, probability of B given A is just the probability of B, all right? And this second result here, which is the test for the independence of two events, is just that the probability of A and B happening is just equal to the probability of A times the probability of B. And that makes sense, right? Because the result we had before with that the product rule that we had before was just the probability of A and B happening. We could get by the probability of A times the probability of B given A. Okay, but we just said the probability of B given A is just the probability of B, right? So we can just rewrite that as the probability of A times the probability of B. Okay, so if two events are independent, we can just multiply the probability of A times the probability of B. Okay, so let's do this example 7 too, because it's pretty short. We're going to apply the test for independence, but we're also going to think back to the terminology that we learned before about mutually exclusive, because these are often confused. Remember that mutually exclusive means that those events cannot happen together. They cannot happen together. And so if they cannot happen together, then the probability of E, the intersection of the two, right, which means that E and F happen together, is the empty set, right? Or well, it'd be 0, I guess. Right, just be 0. Okay, there's the probability is 0. And if they're independent, then we can multiply the probabilities to get the probability of both E and F happening. All right, so let's test this. So in here we're just given some probabilities. All right, we don't know any context around where these probabilities came from or what they apply to, and we just want to figure out whether they're mutually exclusive, and we want to figure out if they're independent. So we're gonna first of all test for mutual exclusivity. Now, the probability of E intersection F, we're told, is 0.2. So that means it cannot be independent because it's not equal to, or sorry, it cannot be mutually exclusive because it's not equal to 0. So that's saying that there is some chance that E and F can happen together. And if there's any chance that E and F can happen together, then they are not mutually exclusive. So this is not mutually exclusive. All right, let's look at the second part, which is testing for independence. Now, to test for independence, we're just going to look at the probability of E times the probability of F. We're going to use that test for independence that's right up here at the top of the screen. All right, if we multiply those two together, we get 0.5 times 0.4, which gives us 0.2. All right. And that is equal to the probability of E and F happening together. So we can conclude that yes, they are. These events are independent. Independent. Yes, they are. Mutually. Okay. So that's essentially what we're going to do. We're just going to use those two tests for mutual exclusivity and for independence. All right, so the same thing here. We just want to test first. If we want to test whether the events are mutually exclusive, we just need to look at the intersection of those events. And if there's any probability that they can happen at the same time, then they are not mutually exclusive. So in this case, the probability of E intersection F we're given is 0.3, which is not equal to 0. So they can happen at the same time, which means that these two events are not mutually exclusive. Mutually exclusive. Okay. Part 2, we want to test for independence. So we just want to take the probability of E times the probability of F. And we want to compare it to the probability of these things happening together. So probability of E is 0.5. Probability of F is 0.7. That gives us 0.35, I believe. Right? Which is not equal to 0.3, which is the probability of the two events happening together. All right? So because the product does not equal the probability of them happening together, then these two events are not independent. Independent. All right. Well, I think this would be a good time for you to pause the video. Don't have to stop it. Try this next one on your own. Think about it yourself, and then you can come back and I'll go through it. All right, so let's take a look at this last one here. We want to test whether these are mutually exclusive, and we're going to do that by looking at the intersection. So the probability of the intersection of E and F, so the probability that they happen at the same time or together, is equal to 0. And that's what we want. That's the test. They're equal to 0, so it is mutually mutually, I can't, it's mutually exclusive. Okay, so these events are mutually exclusive. For the second part, we want to test for independence, and we're just going to multiply the probability of E times the probability of F. So what do we get? We get 0.1 times 0.3, which is, what is that, 0.03? Okay, and that is not equal to 0, right? Which is the probability of E and F. Okay, so these events are not independent. All right, so this last thing I'll just mention, we can also test for independence of more than 2 events. Okay, so if we have more than 2 events, again, and they're independent, then we can just multiply their probabilities. Okay, so I think that's fairly straightforward. So I will meet you in the next video.